And I think with the caching of the forest, the terrain part is like pretty much finished, except the its secondaries and the volume, which is in a different place. So I guess we can move on to that one now. We can call it the I think I name it crack and dust sim. So I guess we can go ground simulations. Here we can say, I mean, it's probably better if we actually move this guy in. You know what? It's like, let's call it that. Let's make it like that, so it's a bit more clear than my original version. Let's drop a geometry node here. Let's call it terrain RBD, because it just makes more sense. And we can cut this whole thing and put them in here, because our the op source is coming from outside anyway, so this is where the simulation happens. We could probably chop a bit more and get it all the way from here, but let's keep it yeah, you know what, let's just do that actually, because all of this is actually simulation, right? So we're gonna do this. Let's come somewhere here. Let's go object merge. Let's clean up our scene. Parameters, pin. Let's go here. I want it down from here. Yes. And I can then cut all of this. Drop it down here. Okay. That should do, right? And I can select these. Okay, I'll just move these guys further down. Okay, so we kind of did a little cleanup. So these were my RBD simulations, except we need to probably be just double checking if our connections have broken, because highly likely. So terrain change wedge, it's no more terrain change wedge, it's terrain RBD instead. This is correct. Just want to check the object merges were from here, so this is all good. Okay, so this is fine. So let's do this now. These, oh, I could have, that's fine. I did the fracturing here also, but it's fine. We could probably remove the fracture into the RBD part as well, but I don't think at the moment it matters so much. But these we need to name a bit better, because this is the forest part. Let's put in a network box. Forest setup. Okay, and because forest is going to be green, these are land, so it's going to be brown. Soil color. Okay, I guess that's it, and we can do this here also. Landscape or terrain. Okay, so this is here, this is here. We cache it out, all good. It comes back in, we can read it. Still, it's not broken. Let's put our camera back in here. And I don't see anything because I broke it. No, it's here. Oh, this one. Yeah, in hero pieces. Was that null somewhere? It was this one, I think. Let me double check that. What do I have here? This should also work now. Terrain fracture 02. It maybe I need to find this one. This should work also. as long as it has the name attribute in inspector spreadsheet, as long as the transform pieces just needs the something to match to the points name attribute, and the orient and other stuff to basically orient it better. Where is it here? Name. All right, so this is good. And our render thing has moved. Now we can go land RBD. This has changed as well. This is now terrain RBD. Yes, and this has not changed. Okay, cool. I'm just gonna save this, and I'm gonna save now as, so first let's save this, and let's save as a new file. Now landscape secondaries, let's call it secondaries. And I think we should probably name this also 01, 02, this is 03, video 3 because, okay, and I am going to rename the other file as well to number 2. Apolcaypse Inferno, this is number 2, rename, and we don't need this anymore. Alright, it's taking shape. And this is probably secondaries part 1. Okay, let's delete the other one, this one. We're gonna have more parts. All right, so let's drop in now in the secondary RBD simulations. Let's name it. Previously I named it Crack Dust Sim. I don't think I'm very happy with it, so let's give it a new name. Let's say it landscape secondaries. My previous one is not very pretty, so I'm going to divide that in a bit more. I'm going to show you now once it stops cooking on my other screen. It wasn't very pretty. It was a bit convoluted, so that's why I want to split it now. There is the volume and the debris. Yeah, it's like its inputs are different and its colliders are same, but I think we can do a better job. Okay, this is now correct. All right, so let's dive inside. So what do I bring? I need to bring my clip simulation source. Basically, we need to use the resource to create some kind of emission area, and that works with in secondaries. Let's call in landscape RBD. Okay, let's pin this, and we know that this is this one. All right, so let's bring this in. And let's go inside. So then pretty much I need to put in the resource. But what we're gonna do is that I think I want to probably, okay, I don't want to bring in the whole thing. I want to bring in, because I want to be able to wedge this as well, so I guess I'm just gonna, where is my landscape terrain RBD? Let's go here. I want to probably bring this in and wedge this value to bring them in chunk by chunk, and then do the simulation. So let's do something like this. Let's copy this entire thing. Let's go in here. Let's paste this. Auto load. So what I'm going to do is, instead of putting the file merge, I'm going to put a file, and I'm going to set that up simulation also in here first. So it's also a child of this guy, so it's it must wait for this to finish. And since this is a wedge, you want a command named wait for all, so it doesn't, so it kind of like combines everything into one finished task and then says, okay, otherwise it's going to do a wedge of that, you know, it's going to go wedge, it's going to wedge for each wedge of this, so it's going to be like many, and we don't want to do that, many simulations. So let's name this change land secondary source. Okay, the names are getting longer. It's the same amount of wedge, so the values are pretty much, actually you can even copy paste it, to be honest. Let's just give it a good name. Obviously this is going to change, wedge cluster, wedge secondary secondary source, and this is what's going to be, you know, the attribute is going to be affecting on the our file node. So there's like read source, read RBD, and let's open the attribute, and we're going to say it's not going to change the target parameter. We don't have a target parameter here. It's just going to change the wedge source by name. So we can say we need to write the rope geo first. Let's dive inside. Let's put in a, let's copy paste this, and let's call it, it's going to be the name anyway, and it's going to be land secondary terrain, actually, or yeah, secondary land. All these names are, you know, you put them whatever you like. I need this to be pinned so I can reference my outputs properly. Let's go in here. So 1 second, I think. So path is going to be what I'm outputting, but what I'm wedging is this is correct, and I need this path to be read back, right? This is because where my simulations are, but instead of file merge $slice, now I need my wedge attribute name to drive the wedging, which is wedge secondary source. So let's go back in here, and it was how with @ sign and the name of the attribute. So basically what's going to do is that you know, this was our output from the previous simulation, and now we're going to read back each simulation one at a time. So look now, this is going to error as you know, as it did before, because we need to generate the values by simply running the wedge node, and it's going to give us values. So let's call in the number 1, not 0 but 1, right? So now this is loading the points here. Let me see. It's, why is it erroring? Because this is reference to something else. Yeah. So let's kill this because we don't have .NET here. Let's put 1000. And if I plug this in, it didn't work because this is erroring. Invalid object merge. Oh, it's not. We didn't bring in the pieces yet. Landscape secondaries. Yes, because this we copied from here. Let's fix that up as well. It was this guy. Was it? Let me check. I think it was. Yeah, this is also the same. Because we copied this to a new geometry node, terrain RBD, we kind of broke all our connections, but now I think it's okay. Yes. So now let's go back in. We don't want to visualize this. We don't want to visualize these. It's a bit slowing down, slowing us down. So let's go to landscape secondaries. Okay. So now, what's happening is, however, this was referenced as well. Okay, we need to bring that to the proper value, which was from here. I think, no, it's from the next one. From here. Here. This is not referenced. Yeah, minus 80. I'm just going to copy this. This was, if you guys remember, we were removing some of the bottom pieces because it was taking forever originally in my simulation to break things down. So here we challenge now a new problem. It's like I have all my sections here, but and there's several fixes for this, but I'm going to kind of use a little code snippet here for you guys can practice as well. So we are loading only one wedge, right? And let's say we forgot to register a wedge ID onto the cache itself, so something that we cannot read from the cache itself. But what we can read, we can read the like what we wedge is that PDG is wedging using an attribute called wedge secondary source right here as we put it. But I cannot use that value. I cannot use that to split my geometry in here, right? It's like, because I'm not reading this from them. So how do I then update? How can I tell Houdini to just read the geometry that has the incoming points? I don't have any reference, like an ID that I can use something to blast. I don't have anything that I can read from a disk to differentiate the disk, because I didn't write this down. Let's say if I wrote this down on the disk as a static state, you know, I could probably do the same thing. But usually this is what I use. There's a wrangle node. There's a function named find attribute value, and it's usually very handy because I use it quite often. So these are my incoming points, right? And these are my static points that will never change. So I'm going to bring this guy as a second input here, and we're going to use the vex function called find attribute value, and then we're going to use it to remove the unmatched packed points. So let's start typing integer match. Actually, I'm going to do the match first so I can show you in the spreadsheet. Equals find attrib val. So what does this do? Let's press F1. It's coming here. As it's coming, I'm going to do this like this. I'm going to continue typing. If you want, you can read it. So it's basically, it's going to look into the other input. It's going to do an attribute match, and if it finds it, if it finds the same value based on a specific attribute, it's going to return a value of I found it, I didn't find it, and these are the examples. Also, for those who don't know, it's like you can type a function, and then while the cursor is on it, you can hit F1, and that's how I opened it. So then, open parentheses says, go to the first input. Well, it's the second input, not 0, but the first one, the second one, this guy. Then look in the point context, an attribute named name, matching an attribute called string name on this left side. So now if I go here, we did a typo. Point name, asset name. Oh, yes, because I want to show it, I have to declare what it is. So it's going to be like a match. Okay, I still made a mistake, I think, because the names are in here and the prim. Okay, so now it's finding some -1s and it's finding some values, and it goes, oh, I found the value and I found -1s. -1s means that I couldn't find, on this side, say -1 says I couldn't find the corresponding name attribute incoming from the right side. and then that's what we want, and we'll say, okay, that's fine. Let's get rid of them. But I don't need to declare this anymore, so I'm just going to go integer. And then I'm going to say, if match is 1, ditch the geo. Okay, so now I only have here. And notice I did something again for optimization. Always keep this in mind. This is read every second. This is not read every second. So this is also not every second. This is not also read every second, right? So if I plug this in here, it will update it will try to calculate every second. Say that, okay, new cache, check, new cache, check, new cache, check. And let me put, maybe it's easier to see if I put the draw time, because it should be doing something with it. Like 3.95 seconds, 5.8 seconds. And if I put this, however, here, now the right side is time dependent, no. Left side is time dependent, no. It's real time. All these little things seriously add up super many farm hours. So it's like, it didn't cost me anything. I just plugged it. This will work here as well. This will work here as well. And if you have really big numbers, if you're rushing through time, and look at this now. If I do a flip book from here forward, let's do this here, and I'm gonna just run a flip book to, let's say, 1080, and this is, I think, quite important. We should probably emphasize on this more. I'm gonna hit record. I'm gonna go to 1080. Well, I need this to accumulate, actually. Sorry. Well, it doesn't matter. So it right now it's, well, I don't need it. It's like 5 frames per second, and if I do that, it's like we lost 1 frame per second, and sometimes more, sometimes less. It's like I say, it adds up, because that's just one part of the work. We're gonna pipe this into the debris source, and it's gonna get bigger and bigger. Anyway, let me save it again. Now what we're gonna do is my current values. So these values are very much dependent on simulation size and everything, and how much you want to squeeze detail in there. But since we optimize this quite a lot now, I'm sure we can just plug this in here. We need to unpack this as well. Okay, so there's another thing. Debris source already doesn't unpack, but we can unpack this previously, and then we don't have to kind of wait too long. I'm gonna cancel this. At this stage, we can unpack it, the transform pieces. As long as we pass the numbers down, it will still work. Okay, I probably should have saved it. No, it's fine. So let's put it on manual. Let's go back here. Let's unpack. Obviously, we're not gonna, because here unpack happens usually in the tool when you use it from the shelf. It puts the unpack here, which is fine. But because we didn't cache it out that way, we cached out points, remember? So we can unpack here. And then we can say pass the name down, and this transform pieces should still work as far as I'm concerned. Yes, and it's like even faster now, I think. And then I can then say, let's reset this, let it cook a second, and if I press play now, as soon as the pieces are, let me put this on template mode. As soon as the pieces are separating, we will start getting some points being emitted. Okay, it's a bit easier to see here and there. You can see on the edge. Let me make these a little bit bigger dots. Yeah, it's also happening a bit inside, but this is all good. All right, we'll need to isolate those later for instances and dust and debris, but that's fine. So obviously outland, this is not outland RBC, this is out debris source. So since this is kind of quite fast, I don't think I'm going to cache this at the stage, but I'll probably pass this down to a .NET to kind of simulate it properly. But now what we need as well is that we're going to cache that out, separate simulation. So we need to convert that guy into a VDB from polygons for our particles to collide with. But this is also not quite heavy, so let me actually try. No, I want to, because what happens is when the particles get stuck inside, they tend to, with the collision, fly around in crazy speed. So I'm going to do something else with it. I'm going to convert this into a VDB, and then I'm going to kind of shrink that. VDB reshape, just a nudge. I mean, we can try actually before. Let's stop this first. Let's put a .NET. Actually, you know, we have the ready one for the particles, which is the PopNet, which is a .NET with the particles. Next thing we can do is now just pipe it in, I guess, into our network. Let's call this debris source pop, or debris, actually debris length pop. Okay, I know that in my previous sim I had some exploding behavior, so I kind of like fixed that with other workarounds, but I guess we can do the same thing here. So when we have the buildings, we're going to have a lot of points stuck inside, but we can do post cleanups regardless. Let's start first with this. So we know that this is our source. We know that this is our collider as proxy field, and we know that this is our geometric. Okay, so out call geo, and we're going to use the same thing for the volume simulation as well, and we're going to use these points for volume simulation as well. And this is out call VDB. Call is in collision, and this is our source. So this goes in here, these guys come here. As optimized as this can be. Okay, let's call this debris source. Let's bring this in now to our PopNet. Okay, so what did I do? I actually did like give them a little different settings in the property. We could have done this outside too, but since the simulation is not so heavy, so I gave them random friction and mass with some expressions. I'll copy paste this here. This is not advanced stuff. So obviously there's a seed, and then seed plus ID is the mass, and then the friction is kind of similar. 0.7 to 1 friction, 0.7 to 1 mass. And I have a pop kill. I say anything that goes down minus 300 meters is like this also. Is dead to me, so they don't fall down forever. I can even probably do this 100 or even less. Okay, this is all optimization. There's a little pop drag, just to give it a little drag, not really something amazing. Pop drag, and it's just the thing is that it's taking advantage of the randomized mass. There is a little. So because I want to instance some of this geometry, okay, I am creating a few inputs. So I'm going to split this. I'm going to name this debris rock. I'm going to name this sand rock, and then debris initial. I don't think I use this. Like if I scattered, did I use this? If I scattered initial points, that I think, yeah, I did. Let's keep that anyway, because it looks strange when there was nothing, like little rocks. But then I had the trees, and it didn't really matter as much. But let's put it anyway, so you can see what I had an intention for. Like if I was, doing this for a future movie, I would definitely have it. Let's go like this. A little bit of connection cleanup. No, I made it worse. Go up, and then you go up. Okay. Next thing is that this goes in the pop solver. Now let's bring in our collision. So merge, left effect right. So let's bring in a static object. And these are in sim, in RBD sim, I guess. Let's pin this. And so this is my geometry. It's a deforming geo. I think let's check if this, yeah, it's possible that it may, it's probably, this is one thing that I don't know. It's like I need to check it better, because you could be telling Houdini to take advantage of the pack prim transformation, but I haven't done my research, to be honest, properly on this one. So I'll use it the way I know it works, which is by forcing it to say that this is a deforming geometry, and then make sure that you take advantage of the VDB field to make it work. There's one thing we need to do. It's called time blend. I'm going to put this here. So if I need to go more sub-steps here, this will come into play, and because I have a consistent point count, then I will be able to get the subframe data into my .NET, and it's just going to work. Okay, we are missing gravity. Let's put gravity. Okay, let me press play now to see what is going to happen. If our particles are going to explode or not. We can hide our geo here and wait for particles to be spawned. Oh, one more thing. Let me disable this for a second. This needs to use all points, I believe. Not all points, but points. I didn't define their amounts, which is also important. Also up to you guys, and how much you want to force your system. General rule, more the better. 3-3 sand rock. For the sand rock, I gave 500,000. Is that correct? No, I put a 5 million here. 3 and 3 again for the debris initial. I am actually saying constant activation until 1003, and then this much. I think I think I want to scatter points on top of the geo and then merge that as a source. Probably that's what I had in mind, but so then obviously we need to say where is the particles coming from. Use first context. Also same, so we can plug this guy in here, and then if I go here now, if I disable this and press play, I should get some points being emitted. Let's turn off the guide visibility. So now I should have just points being emitted and falling down, because I don't have the collider at the moment. Are they falling? These are large scenes, so they are falling. They're just falling real slow. Okay, now this part is working. Let's bring in the collider. And let's see if anything's exploding. Because I had exploding parts and it was kind of like I was struggling. Then I started introducing little parts to cut down. Let's bring back the display geo. Okay. Alright, so I'm going to do something like this. I'm going to give this a red color. Actually, I'm going to give these different colors. And I'm going to do a little play blast to see that it's working. And then we're going to move on to the next stage in the next video. Because I think we are getting a little over our time. So let's make this an R, G, B. And honestly, I think this needs to be just scattered on top. Let me see if we can do that here actually. Initial state. So we can actually put some rocks on them. If I do a blast, it should be the only outside, and that should actually work. Not this one. One of these should work. I want only what's outside. So get rid of everything inside actually. Okay, it's not really, didn't get anything. Oh, this is the original one. Let's go like this. Should get some more out. It's not really getting rid of anything. It is not cool. We can do something like in a different way. Well, you know, that's not so difficult. You can always do something like this. Put a box. Not the most efficient way, but it will work. Let's blast the top, delete. I have this geo at the bottom right. Okay, scatter points. Sure, these are the rocks, right? Already rested rocks, like our trees. Grade down to this guy and say project raise attribute not vector -1. Okay, so it shoots some, it didn't shoot some, and if we turn on, look at the point attribute, and if we turn on point intersection distance, some will be 0, so we throw away the 0. If f at dist equals 0, remove point on self. Typo. Okay, now it removed anything that didn't land on anything. All right, these are our rocks. There's a few misfits, but it should be okay. Then we can say this one out initial. So this part is like out from simulation. This one is like there were rocks already on top. Out debris. Out initial source. Initial. Okay, and we'll go here and say this guy is using second context geo. That is this one. Okay, little problem is solved. And we're gonna say this one is, it's gonna basically emit every frame, but in a bit more random place, I guess. Or we can say constant, maybe 1. Let me disable this to see how if that's gonna work first. Always debug your scenes one at a time. if you have sources, if you have collisions. This is how I debug usually. So they're falling down, they're blue, and they're emitted only one frame, I think. We can probably do a $F for the seed to move them around a little bit, so they're not on top of each other. Is it 1000? If the $F points, all points, what's the points? We're not using the surface, but it's keep adding. Why? Is it still on? No. Oh, maybe this. I don't want to add points. Is how many adds in one frame? Sorts points. Let's do all points. And then let's do 2. Oh, this is 1. Okay, let me try this. Okay, then we do $F less than 1001, so it should emit only once. Okay, so then we can go and say more points. Okay, and if I go down here now. Okay, so these are my rocks, right? These are my sand, and these are my debris. So I guess we're gonna play with the sizes and stuff, but we'll see. Alright, so if I press play here, I'll get different colors from the cracks. I'm not getting any red. Probably I'm getting a bit too many green. I have collision at the moment, but and green is this one, so let's make this green, let's make this blue, let's make this red. Debris, and this one is gonna be 50,000. Yeah, now I see them a bit more. Yeah, it's just to add a bit more variety, I think, in terms of size and weight. Now let's turn on the collider. I'm gonna save. Let me press play, and then we'll do a little end play to see where this goes in 50 frames, to see if it kind of makes sense and if it kind of feels right. We can add things like pop interact. I think I do have a pop interact, or maybe we can, excuse me, we can pass some of these from grain, but to keep it light, I didn't do it honestly. Let's just put a pop interact, I guess. Pop interact is a bit faster than pop grain. Well, not really, but it's a bit, let's say, on the light end. So stream. So this I want to be the sand. So basically, I want the velocity. So like it kind of takes all the. It's gonna take all our green particles, and then it's gonna, like, as if a little slightly wet. It's gonna treat them as one thing. So it's called stream sand, and I want this to work on stream sand only. So I'll put on stream sand here. Okay, and then that is for now it. Let me save again, and we're gonna do a flip book, and we're gonna come back in 100 frames or so. Let me make this a little bit bigger, so it kind of makes more sense. Where is the flip books here? Second. Am I changing the resolution? No. Die. Okay. Yes, I was. Let's disable that. If you want to get rid of that black bar when you look through the camera, you can also do this. This one makes it black. I like to work it like that, but for play blast, it's here. But for now, this is fine for us. So the collision is on. Particles are falling. We're making a flip book. See you in a few minutes. Okay, so I did a little bit more adjustment than that, and I think it's so much nicer now. First of all, you remember the part that we talked here, like isolate wedges. I did something similar there, isolate for test. So because this was our patch, right, and it was still not so fast, so I kind of like created like a bounding box for some, you know, lesser amount of much lesser amount of pieces here, just this section here. And so what I'm doing is I'm blasting using the same technique, but this time running on points. I'm blasting everything else, so this is the moving part. All the points are coming from here, right? And then I'm, you know, it's doing the same thing here after the delete. So when I have to do the full thing, I need to disable these guys. But now I'm testing, and this is the part that I can see here. That is kind of edge separating. This is like the edge that follows the land, and this is the center. So it's like a perfect area for testing. So now, what happens when you just pipe it in? I'm going to disable this in here. I'm going to keep this, guys. And if I press play, I think the angle is something like this. And also kind of balanced these, like we don't want so many reds, we don't want so many blues. And the green is this sand, so we can have many of those. But these are going to be instants, so we don't need so many of them. So if I press play and let it cook a little bit, what happens is that because this is such a big mass, and you expect dust to get kind of pulled with the land a bit more, but because we're not creating any medium, it kind of like as soon as a piece starts falling, it kind of separates itself from it and doesn't follow the trajectory of this massive chunk beneath it. So then you end up seeing things like this green getting separated from the land itself too easily, and whereas you expect it to kind of like flow with it, right? Because it's a big geo. Like imagine you know, like a huge land collapsing. You want dust, you feel like the dust would get sucked with it, with the landscape. And so what I did then instead is I said, okay, I need the velocities from the land to be injected, not just collider, but to be injected into the simulation. So how does that work? I put a soap solver that is calculated pre-solve. It's probably okay during the post solve as well. Let's call it land advect. Okay, and if I dive inside, I'm doing something very simple. I'm just bringing the collision geometry, which has the velocities. I rename the velocities to V2 advect. I'm renaming it to, well, I could have used a rename tool as well here, I guess. To rename. I'm creating an attribute called land advection, and that is equal to velocity of the land, which is coming from my simulation. So then I go bring in the velocity, bring in the advected velocity or land velocity, whatever I named it, land advection. Then attribute transfer those onto the simulation points. Right, it's land advection, but I'm adding that as a force on top of the forces coming from the right side, right? Like if there's turbulences and that. So now it's adding it up as a force. So if there's a huge mass being pulled to the left, the particles within the 5 meter radius will get advected based on where that land mass is going. So I'm going to show you this example now. Out advection force. Okay, and in a soap solver, you always want to keep the display flag where you want the last calculation to be. So if I dive inside and I press play, I end up with this. So now stuff is getting a bit ripped apart nicer, and then you can see the trajectory is a bit nicer. Of course, we still have some issues, like, you know, it's like this would be really nice if this was actually kind of in and out. So you could probably utilize something like a bit more random based on, let's say if I come here like this guy, I can give it a, say, warp, point warp. I can actually use the mass. I have a mass, but here's the problem with the mass that we have in here. Let's fix that up as well. This mass creates a mass with, actually I'm going to completely destroy this because it's like there's no structure to this. It's like the mass and the let's we're gonna create, actually let me put a wrangle here, because it's like one particle can be a mass of 5, the other one can be a mass of 0.7, and they're very close to each other, so visually it will be very difficult to notice, right? So let's do something like this instead. Let's give it a visual distance. So this is our small chunk here, right? So if I go turbulent noise, so now it's a bit too high frequent. So if I go like this, so I have a bit more broader whites and blacks. So on bind export, I'm going to say mass and friction, and then because we don't want zero mass particles, let's do a fit. Let's just make sure that these are not, don't calculate. Let's make sure that these are not, yeah, they're not vectors. We want, what, let's say 0.5. Okay, now if we do the same thing again, it should be a bit more interesting. Because we need to also then multiply these force plus equals v at land advection times at mass, right? So some will get affected, some will not get affected as much based on the color, that based on the black and white image we give it, that has a recognizable distance that we can see, because then it's going to be like some, it's going to almost like, instead of randomly picking this moves, this doesn't, it's going to have a fall off, so visually we can recognize that. We broke it. Okay, the blue doesn't have any, nothing's happening to blue. Why? Did we break something with blue? Blue doesn't have, why is the blue not working? Everything else is working. Oh, because, sorry, yes, because blue is coming from here, so we had to do the same thing to blue. Oh, actually blue is a debris, and probably it, that's fine. But the debris should fall fast, right? So they at least need to be a lot heavier. So let's call it 1 to 2. Oh, but we want, actually we want heavier things to be less advected. So let's call this not mass. So the mass should be 1 to 2, but we want to reverse that. Let's say 1 to 0.2, right? For advection, advection force, advection mult. Let's call it advection mult. And basically the debris should not get so much affected because it's heavy. So it should just go down by itself, because we're going to assign debris to it. We're going to assign geometry to it, so it's not sand. It should still have mass, which should be heavier, 1 to 2, okay. It should still have friction, 1 to 2, let's say is fine. But advection multiplier should be 0.1 to 0. Let's say 6 for these guys. I'm gonna copy this again, but here is our regular particles that we do want them to get affected more. So in this case, this will be equal to reverse. So these are dust, right? So we're gonna go destination. So the lightest one is, let's say 35, and this is 1. And if it's less than 1, let's say in this scenario, it's like if the mass is more than 1, it's an instance. If it's less than 1 to 0.35, it's a dust particle. Therefore, heavier it is, more affected it is. So this is kind of correct. We can actually use the mass for that one. But because we're passing it all through one thing, so it's going to be something like this. Okay, advection mult. ADV mult. So we are going to go in here now. Hopefully I didn't make it wrong. Instead of mass, we're going to use this, and let's see what happens. Is it moving? It is moving. Let's see what happens now. It's a bit more random, I guess. You could definitely use more green because let me see if we can push this a little bit further. Yeah, we can probably give them a bit more life as well. Okay, and what if we give a little bit surface also? Okay, now let me have a look in here. Obviously we slowed it down, but I think it's gonna work better. And yeah, I think obviously the test area is yeah, I mean, like it's a lot less hard cut emission stopping here now. It's a bit more mixed up inside. I think this might work fine, to be fair. So it's a bit more, everything's a bit more here and there. Gravity is taken over. And then we can see some particles being pulled with the land as if they're being advected by a volume simulation, but they're not. Of course, if we get notes like, oh, it feels like they're floating too much, you know, we can just say advect less and they will start going down or increase their mass in this case. Okay, cool. So this is working. So what we're going to do now, obviously, is disable this section. So we get the entire, zone, and if I press play here, you're gonna see the entire thing emitting points. So now, because we kind of disabled, I'm gonna add one more 0 here, and on here I'm going to add one more. This is the section, right? I'm gonna add a bit more surface rock. Put another 0. Okie dokie. And now what we're going to do is that sim a few frames. Just until we have all the green and red particles out. We have a few red, we have a few green. Okay, good. So let's set the conditions for caching this out. So we don't need everything. So let's call this dust. Let's call copy. We want to pull out only the dust. Then we want to do an attribute cleanup for sure. and that's usually, we just need at this moment everything but velocity, ID, probably mass. Yeah, I think that should be enough. Clean up. So the names are usually a little bit more, you know, not clear enough here. So I'm gonna group delete group delete the groups coming from the geometry, because we did the scatter, so they inherited these guys. So I don't want anything with concrete. Actually, I don't want anything except stream, I guess. I don't want anything except, oh, we have a name. Get rid of the name, get rid of this, get rid of that. Yeah, I need that as well. Oh wait, I might need that for instancing. But we can, anyway, let's keep it. 1 second. Now I have, okay, this is cool. So I don't want anything but stream as a group name. So let's blast every other group. And that the way it works is that I'll say stream using wildcards, and oh, the opposite. Okay, so no, prim groups, primitives, delete everything. But why are you not deleting everything on primitive? Okay, that will do. I want to rename these. I am going to just, there's a group rename node, but it's already not going to work because I already changed it inside the .NET. But send is basically stream send, just a send. Stream debris rock to stream debris initial and stream debris. Okay, so 2 groups. We need to, I guess we can do that, and here we need to get rid of the send as well. Our point, our send. So here I am now, I only have, okay, I'm gonna add, because I'm gonna store these as particle sims. So it's, some renderers care about this, some don't. So now I add a particle system. So it's a particle system. It just basically is a primitive. And ID, velocity, stream debris, all good. Now, regarding how to store this, is instead of, actually, let me see if I go auto. Let's go to the first frame. Okay, I'm going to, you know, I'm going to pause. I'm going to go to 1040 and I'm going to come back. Okay, so this cache now until 1040. So we're going to do something different now. We're going to store our points as VDBs. So VDB can store points. We can pack them. We can convert them to VDB. And why we're going to do that is it's somehow not very common. Mantra cannot render VDB points at this moment. As far as I know, Randerman as well. I actually don't know. I mean, some of the studios I've worked, they do keep their points as VDB, and I think to save disk space and to sample faster. But now, because we don't have such access to such technology, we are going to just use that for storing the data with saving disk space purposes. So at this point, I have only points. I have 900,000 points. Okay, I'm just gonna cheat it a little bit. I'm just gonna want to make show you the difference to be a bit more. So pop replicate, point replicate here, point replicate. Okay, and let's go 10. Yeah, let's go like numbers, randomized. So here, so we have now 1 million. Let's go a bit more. Okay, 5 million points. Let's go crazy. Okay, 25 million points. So if I do a little file cache here, single frame, I don't want this dirty, this thing, so I'll just save it on my desktop. particle geo dot bgeo. Oh, I see. Okay, single frame, current frame. Let's just cache this. Okay, let's see if this worked on my desktop. Okay, so it's 212 megabytes. All right, so let's do something different now. So let's go here. Let's go convert to VDB points. So now it's a VDB with a field, and I'm like really clamping these values, like 8-bit fixed. And if you want to see the size, you can play with the points per voxel. So this should kind of like start getting bigger. If I go, I guess 25, I get more. If I go 500, a lot more. So let's do a few tests. Let's call VDB. What is this? 500, right? Not doing to save it, obviously. Let's do save. And now we are kind of storing the same amount of particles with some compression. 80 megabytes. That's a lot of disk space saving. So if I go 100, I think now it's going to go a bit higher, as far as I remember. Well, it's not that much worse. So this is like we saved a lot of disk space. So instead of, let's say, imagine having all this 2 terabyte of point data, now it's a terabyte of point data. The problem with this is, so what did it do? It shaved some points, floating points, which super unlikely for us to see, because this is like, remember, that's a centimeter, right? So that's a meter, sorry. So that's a centimeter. That is the centimeter, right? Decimeter, centimeter, millimeter, and super small numbers. Our scale is massive. I believe that's just 8-bit fixed point. It doesn't say, but what happens if we load it back? Let me see, because we cached it here, and I can do a load. And then, however, to render this, you need to load this back in and then say convert VDB points, in this case here, back to exact points with VDB points. So it kind of like, I guess it's not going to be easy to visualize that, but it's, I mean, it's not the same point. Obviously, we probably need to do that like a bit of blast. Let me see if that works so we can see the actual difference. Remove everything. Give me 1 point. Well, it didn't do anything here, I guess, but I guess it did something with the big numbers. Anyway, the point is, by converting our simulation to VDB points for regular particles that are going to be dust and debris, we have shaved a lot of information. Did I also remove, however, I don't have the orient. I removed the, 1 second, where am I removing some data somewhere? I have the ID. Oh, this one was, this is, don't worry about it. Those, because we didn't turn on the copy information. So let's do this again. Let's do it again anyway. For a smaller size, so it's going to be a lot less now on the particle BGO. Particle GO is 2.4. I think the scaling gets much bigger once it's let's say this. So like 2.4 to 1.9 megabyte, but like I said, like we did here, VDB, what was it? Let's do it again. Point replicate. Point replicate. I made a mistake there. 1 second. Point replicate. No, I didn't actually. I did what? 250. Yeah, go there. Keep attribute. Copy all the attributes as well. Copy source attributes. Keep source attributes. Let's go here. Let's go here. Once again, that's 24 million points. They all have all the attributes, so it actually has extra attribute. Okay, that's good. Let's do this test again. Particle geo, save, convert to VDB. We can visualize the tree here. I'm gonna make the tree size a bit bigger. So if it's the tree size is a bit bigger, it kind of takes a bit longer to pack. The number of points per voxel to use as a target or automatic voxel size computation. So I don't know actually the difference, what happens, why, like it has actually more use we can probably find, but let's go a bit smaller. I think it doesn't load the buckets as well. If you could render this, like it would ditch the buckets that are not visible, and we can do operations on this, I believe. Okay, let's save this now. So this one is 100. It's not 100. Sorry, it's 250. So now we're going to compare the file size again. Let's load this back in. Again, we have all the files and all the number of particles and everything is there. And if you look at the file sizes, desktop, this is not the one, as opposed to raw particles 214, VDB particles 100 megabytes. So we shaved off a lot of disk space, and from now on this is how I'm caching my particles as well. Just to render it, we just have to convert them back to particles until they are ready. So we are ready to cache at this point from here. So we'll name this out land RBD, and this is now going into our secondary LAN here, this guy here. So pin it, go in here, and it's this one. Okay, so what's going to happen, that it's going to edge, right? So the best way to see it is to make sure that it's working. I'm going to turn the auto update here. Then I'm going to pin this one here, go into simulations, and if I click some of these, this should change to a new location, to a new wedge. And then based on this wedge value, which is wedge secondary source, which means I need to change the name here as well, otherwise it's not going to work. Okay, now we are ready to cache this portion, and after that we can move on to our Pyro simulation, and then finally we can start our buildings. All right, I'm going to pause this video now, and we'll see you in the next chapter.